Alright, today we're going to be doing 8-8, factoring difference of squares. And our objective today is to factor binomials that are difference of squares, and we're going to use the difference of squares to solve equations. And I will tell you right now, this is my favorite type of factoring, and the reason why is because I find it to be the easiest type. Okay, so let's start looking at some examples. Well, difference we know means subtraction. And squares, what they mean by that is perfect squares. So in order to do these type of problems, you need to have a subtraction sign, okay, which is what we have right here. And then you need to have perfect squares. Remember, our perfect squares are 1, 4, 9, 16, 25, 36, and I'm not going to write them all out because we did that before in one of our notes, and it keeps going. And remember, to be a perfect square with a variable, it means the exponent has to be even. So you would need to have like x squared, x to the 4th, x to the 6th. All of those are perfect squares. All right, so looking at our first example here, we've got 16h squared, which is a perfect square, minus, there's our difference that we're supposed to have, 9a squared. And that's another perfect square. So what you're going to do here is you're going to do two sets of parentheses. And you're going to take the square root of the first term. The square root of 16h squared is 4h. And we're going to put that in the front of our parentheses. And then you're going to give one a plus, one set of parentheses a minus, and then you're going to take the square root of the last term. Square root of 9a squared is 3a. And there it is factored. 4h plus 3a times 4h minus 3a. Let's look at another example. Example 2. Okay, notice that both terms are perfect squares and they are separated by a minus sign. So that means it's a difference of squares. So now I'm going to do my two sets of parentheses. I'm going to take the square root of 121 and I get 11. Put that in front. Give one a plus, the other one a minus. And then the square root of 4b squared is 2b. And there's your answer. 11 plus 2b times 11 minus 2b. All right, example 3. Now, is 27 a perfect square? No. And g to the 3rd, remember I told you that our exponents have to be even. So 3 is not even, and then over on the other one, 3g, that is not a perfect square. So we look to see if there's any other type of factoring that we can do here. And I see that there's a GCF here. And if at any time you see a GCF, you always do that first. That's why we learned that one first. So our GCF here is 3g. And then remember, when you do GCF, you get to one set of parentheses. And then divide each term by that 3g, and that gives us 9g squared minus 1. And now looking inside the parentheses there, we have 9g squared, which is a perfect square. We've got a 1, which is a perfect square, and they're separated by that minus sign, so we can go ahead and factor that even more. So we're going to take this right here and factor it. It's a difference of squares. So I'm going to do two sets of parentheses. Take the square root of 9g squared, that gives you 3g. Put that in front. And then one gets a plus, the other one gets a minus. The square root of 1 is 1. And then it's very important, don't forget to bring this GCF down. The 3g needs to go in front. And now this one in blue is your final answer. That has been fully factored. Okay, let's look at another example. Example 4. We've got b to the 4th minus 16. Those are both perfect squares, and they're separated by a minus sign. So that means we can do difference of two squares. Two sets of parentheses. Take the square root of b to the fourth. Remember, all you do to take the square root is take that exponent and divide by 2. So that gives us b squared. 1 gets a plus, the other one gets a minus, and the square root of 16 is 4. Now let's look at our second set of parentheses. Notice we've got a b squared minus 4. That is, b squared is a perfect square, 4 is a perfect square, and they're separated by a minus sign. So that means that these are a difference of two squares, a difference of squares. So we can factor it. And so that's what we need to do. Do two sets of parentheses. The square root of b squared is b. 1 gets a plus, the other one gets a minus. The square root of 4 is 2. And then very important, just like in example 3, make sure you bring that other stuff down. So in front, we need to write b squared plus 4. And then everything in red right here is your final answer. Okay, let's look at example 5 now. Example 5, we've got 625, which is a perfect square, minus x to the fourth, which remember, since x to the fourth since it has an even exponent, it is a perfect square. So let's go ahead and do our two sets of parentheses. The square root of 625 is 25. 1 gets a plus, the other one gets a minus. The square root of x to the fourth is x to the second. All right, so take a look at that answer. Do you see anything else that we need to do? You should see right here, we've got another set of difference of squares. So let's go ahead and factor that. Two sets of parentheses. Take the square root of 25 is 5. 1 gets a plus, the other one gets a minus. The square root of x squared is x. And then bring down the other guy, 25 plus x squared. And there is your answer. All right, let's look at example 6. Okay, first thing that I see here is that we have got 4 terms. 4 terms, so definitely not going to be a difference of squares right now. But remember, the first type of factoring that you always look for is this is very important. It is the GCF. Always look for the GCF. In any type of factoring, look first to see if there's a GCF. And when we look here, we should see that we've got a GCF of 7x. I'm sorry, not 7x. They don't all have an x. It's just 7. So we are going to do 7, one set of parentheses, and then divide each term by 7. So that gives us x to the third plus 3x squared minus x minus 3. All right, next. After that, I don't have a GCF, but I still have 4 terms. And you should know that whenever you've got 4 terms, the best thing to look for is to see if you can factor by grouping. So let's group these first 2. Okay, in the first 2, I see that they have an x squared in common. And that leaves me with x plus 3. And then look at the last 2 terms. And what we wanted to have is an x plus 3. But I see I've got a negative x minus 3. So that means I need to pull out a negative 1 to change those to its opposite. And now it's going to be an x plus 3. All right, so now remember the grouping method. Those two sets of parentheses are the same. We just bring it down once, x plus 3. And then the leftovers go in the other set of parentheses, x squared minus 1. And then remember this 7 right here? We can't forget about that guy right there. That 7 needs to go in front right there. Okay, so now let's look at our answer and see if we're good with that. Most of you would probably say yes, but take a very close look at this last binomial right here. Notice it's a perfect square. Both of them are perfect squares, and they're separated by a minus sign. So that means it's a difference of two squares, so we can go ahead and factor it. Do two sets of parentheses. One gets a plus, the other one gets a minus, and the square root of 1 is 1. And then remember, don't forget about the other stuff. We need to bring that x plus 3 down. And definitely don't forget about that 7. And now our answer is done. So we've got 7 times x plus 3 times x plus 1 times x minus 1. All right, let's look at example 7. So on this one, we are solving. So let's remember our steps. First thing we need to do is set it equal to 0. This is not set equal to 0, so we're going to subtract 121 on both sides. Now understand that over on the left side, those are not like terms, so we cannot combine them together. So that's going to be 36w squared minus 121 equals 0. And then we notice, hey, those are both perfect squares. So I'm going to do difference of two squares, two sets of parentheses. The square root of 36w squared is 6w. One gets a plus, the other one gets a minus, and the square root of 121 is 11. And now we take each factor and set them equal to 0. So I've got 6w plus 11 equals 0. And then 6w minus 11 equals 0. And then we're going to solve each one of those. So I subtract 11. That gives me 6w equals negative 11. Divide by 6. And there's our answer, negative 11 over 6. Leave it as a fraction. And when we do the same thing over here, we're going to add 11 this time. That gives us 6w equals 11. Divide by 6. And this time our answer is 11 over 6. So you could see the answers written like that, where they're separated, or you could see your answers where it says positive negative 11 over 6. You could see it written either way. Okay? Let's look at our last example here. So we're going to be solving this. Our first step is to make sure it's set equal to 0. So we're going to go ahead and subtract that 16. So these are not like terms, so I'm going to go ahead and write 1/4 b squared minus 16 equals 0. And then notice, even though I've got a fraction there, that fraction is a perfect square, because 1 is a perfect square and 4 is a perfect square. So that the 1/4 is a perfect square. So that means we can go ahead and factor it by difference of squares. So you do your two sets of parentheses. The square root of 1/4 b squared, well, the square root of 1 is 1, the square root of 4 is 2, and then the square root of b squared is b. So that means it gives us 1/2 b. And then the square root of 16 is 4, so I do plus 4, and then minus 4. All right, now you're going to set each factor equal to 0. 1/2 b plus 4 equals 0, and then 1/2 b minus 4 equals 0. Subtract 4 on both sides. That gives us 1/2 b equals -4. Now, how are we going to get rid of that 1/2? Many of y'all are going to say, oh, change the 1/2 to a decimal. That's okay on this for this one, but what if that was a 1/3 or a 2/3 or 1/6? You need to know to get rid of a fraction that's being multiplied, you multiply by the reciprocal. So that's going to be 2/1. 2/1. So those are going to cancel out, and we get b equals -4 times 2 divided by 1 gives us -8. Now let's do the same thing to the other equation. So we're going to add 4 to both sides. That gives us 1/2 b equals 4. Same thing, multiply by the reciprocal over here. 2/1. 2/1, so those cancel out, giving us b equals 4 times 2 divided by 1 gives us 8. So our two solutions here are -8 and 8. You can write it like that, or you can write positive and -8 like this. All right, that's it for our notes. Be ready for your notes check tomorrow. And if you have any questions, please let me know.